Alright, this is the fourth and final part of our lesson on inscribed angles and circumcenter. So in the other three parts we talked about inscribed angles and the intercepted arcs that go with them. But this is the part where we finally get to talk about circumcenter. In order to talk about circumcenter, we need to understand what a perpendicular bisector is. Alright, let's talk about what a perpendicular bisector is. It should be self-explanatory if you know what perpendicular means and if you know what bisector means. Now, perpendicular means forming a 90-degree angle. So, for example, right now, if I go like this, the segment and the line are not perpendicular because this is not a 90-degree angle. Alright, so I could sort of rotate this around until it began to form a 90-degree angle. Not quite there, getting there. Alright, getting closer. So something about like this, and I'm just using my eyesight. But this looks like it's about 90 degrees at this point. So that would make the line and the segment perpendicular. Alright, so that's what perpendicular means, forming a 90-degree angle, a right angle. Now, let's talk about what bisector means. Bisector, to bisect means to cut something in half, right down the middle. Let me move this aside for a second. If you look at this segment, you can imagine that it has a midpoint right here. Alright, that means that either side of this segment will be congruent. Now, if I let this line pass right through the midpoint, then I could say that the line is the bisector of the segment because it's cutting the segment in half. And since I made it perpendicular, it is now the perpendicular bisector. It's perpendicular, 90 degrees, and it's the bisector. It's cutting the segment in half. Okay, so that's the first thing I needed to make you understand. Now, the perpendicular bisector is very involved with something called the circumcenter. Now, a circle has one center. If I say look at the center of the circle, everybody knows what I'm talking about. But if we want to talk about the center of a triangle, it depends on what you mean. There are several different ways of talking about the center of a triangle, and we're going to talk about one of them right now. One way of thinking of the center of a triangle is if you draw a circle through the vertices of the triangle. Alright, so if you have your triangle with each of its vertices on the circle, the center of the circle you could think of as also being the center of the triangle in some sense. When you think of it that way, that type of triangle center is called the circumcenter. Okay, so see this vocabulary word right here, circumcenter. So obviously, if you have a situation where you have a circle and a triangle is inscribed inside the circle, and the center of the circle is the center of the triangle, if I draw these red lines like this, I'm hoping you can see that each of these three lines will be equal in length because they are radii of the circle. And so no matter which direction I go, it's going to be the same distance. So if you have a circumcenter, then the distance from the circumcenter to each of the vertices is going to be equal. Alright, the distance to the corners will be equal, equal, equal. Alright, that's key. One more thing you need to know about a circumcenter is the way you find a circumcenter is using perpendicular bisectors. Let me show you what I mean. Alright, look at this green triangle. I don't need to draw a circle around this triangle to find the circumcenter. what I need is to draw two or more perpendicular bisectors. So for example, if look at the bottom side, if you as carefully as you can find the midpoint of that side. So a bisector is going to go through the midpoint. So now if I go ahead and draw myself a bisector here, but I'm going to make it perpendicular. Okay, so it's right in the middle, so it should be a bisector, and I'm trying my very best to make it perpendicular. Okay, so this is a perpendicular bisector. Now if I do that on another side of the triangle, so over here, now granted I'm not using a ruler or anything, I'm just eyeballing it, but this seems to be about the center of the midpoint of this side. So again, I'm going to make another perpendicular line. Okay, so by putting it at the midpoint, it's going to be a bisector. Now I'm going to try my very best to make it perpendicular as well. I think I'm doing a pretty good job. It's hard to know for sure. Okay, now assuming that I did a good job and made this the perpendicular bisector, okay, because these should be the same and these should be the same. What I'm telling you is perpendicular bisectors of a triangle are going to meet at the circumcenter. So this should be the circumcenter. Alright, I only need two of them to get the job done, but if I did it again, if I did it right, the third one should meet at the same spot. Okay, so let's say if this is the midpoint of this side, if I make one more perpendicular bisector, okay, it should also meet at the circumcenter. Okay, and there you have it. So this is the circumcenter right there. Okay, now remember, so you can find the circumcenter using perpendicular bisectors. But once you find it, don't forget the key thing to know about a perpendicular, not a perpendicular bisector. The key thing to know about a circumcenter is this. The distance to the vertices should be the same. Okay? So, if this is the circumcenter, then this distance, okay, and let me make it a little bigger, and this distance, and this distance. Alright, if this is the circumcenter, then the distances to each of the vertices should be the same. These three distances should all be equal. Okay, so if this is 10, for example, then it should be 10, 10, 10. Alright, so I know that's a lot of information. We learned what a perpendicular bisector was. We learned that if we form perpendicular bisectors of a triangle, they will meet at the circumcenter. And then we learned that the circumcenter will be the same distance to all of the vertices, the corners. So we need to put all that information together to help us answer these questions. Okay, so in the diagram, the perpendicular bisectors of ABC meet at point G. Okay, so these blue dotted lines are the perpendicular bisectors. Okay, that's what they're trying to tell us. So they're telling us that this is, 90 degrees, and they're telling us that, for example, this and this are equal. So because it's a bisector, it splits it in half. So if this is 20, for example, then this is 20. Alright, same thing is happening over here. This is a bisector, so this should be a midpoint. So if this is 15, this is 15. Same thing over here. This is a bisector. Okay, So F is the midpoint. So if this is 24, then this is 24 over here. All right. Also, if this point G is the intersection of these perpendicular bisectors, that means that point G is the circumcenter. All right. G is the circumcenter. Okay, because that's what you get when you cross perpendicular bisectors inside of a triangle. And if G is the circumcenter, like we talked about before, then the distances to the vertices should be the same, like 10, 10, 10, or 20, 20, 20, whatever it is. So in this case, these three red lines should all be the same. All right, the distances to the vertices, because these will be the radii of some big circle that we can't see. Okay, so if we find one of the red lines, then we found them all. Okay, so let's see what they're actually asking us for. Find AG. All right, let's see what that's about. All right, AG is one of these three red lines, right, from A to G. All right, so here's what we're going to do in order to find AG. If you look closely, we are given one of these three red lines. All right, one of the distances to one of the vertices, we're just flat out given that number. Can you see it? It's right here, my people. All right, GC is 25. Now the circumcenter is the equally distant or equidistant to the vertices. So if GC is 25, that means GB is 25 and GA is 25. All three red lines are 25. So AG is 25 for that reason. Okay, what about BD? See, where's that? BD. Well, BD is 20. We talked about that before. This is a midpoint, so 20, 20. BD is 20. Okay, what about number 25? CF. Let's see what's up with CF. CF is 24. Same thing. If that's 24, then CF is 24. Okay, easy peasy lemon squeezy. What about BG? Alright, BG is yet another one of these red lines. Alright, and if one of them is 25, then all of them are 25. So BG is 25. Okay, what about CE? Okay, CE is 15. Again, E is a midpoint. If that's 15, then this is 15. So CE is 15. What about AC? AC is 48. All right, AF is 24. That means FC is 24. So the whole thing is 48. So AC is 48. Okay, so that's it for that picture. Circumcenter. All right, is what G is. Now, I think number 29 is similar. The perpendicular bisectors of triangle ABC meet at point G. So once again, guys, that means point G is the circumcenter. And that means as soon as we see that we've got the circumcenter, that means the distances to the vertices will all be the same. Okay, I'm going to highlight them in red. So this is the circumcenter. So here's the distance to one vertex. Here's the distance to another vertex. Okay, messed it up a little bit, but that's okay. And here's the distance to the third vertex. Okay, those three red distances should all be the same. And we know what they are, because AG is 10. That means they're all 10. That means this is 10, and that means this is also 10. They're all 10. Okay, so just keep that in mind. Also, as long as we're at it, these are perpendicular bisectors. These dotted lines are the perpendicular bisectors. That means D is a midpoint. So if that's 8, then this is 8. Okay, do I have any more of those? Okay, that's it for the easy ones. Let's see how far that takes us. Find BG. Our goal is to find BG. Okay, BG is 10. That's it. Kabam. Alright, it's the circumcenter. That means all three of these distances are the same. Okay, so that was, is that it? Yeah, I guess that was it. Okay, this is the last problem. Let me make sure before I lie. This is the last problem of the lesson. Okay, you and two friends plan to exercise together. You want your meeting place to be the same distance from each person's house. Explain how you can use the diagram to locate the meeting place. Well, what you can do, if you think of the three houses as being the vertices of a triangle, okay, sort of like this. Bam, 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 and bam. Alright, the vertices of a triangle. Then, hold on for a second. If we want the meeting place to be the same distance from each of these vertices, then what you want is the circumcenter. Okay, so we need to find the circumcenter. And of course we learned that we can find the circumcenter by drawing perpendicular bisectors. So let's write up what we just said and then we'll do it. Okay, so we're supposed to explain. The three houses are the vertices of a triangle. The meeting place will be the circumcenter. Alright, you see, because the circumcenter will be equally distant to the vertices, the three houses, and that's what we want. We can find the circumcenter by drawing perpendicular bisectors. Two or more perpendicular bisectors. Okay, I want to get the word intersection in here somewhere. Maybe instead of drawing, I'll say intersecting. Alright, can I use intersecting as a verb? Well, by intersecting two or more perpendicular bisectors. I think it works. I'm going to go with it. Oh, but I spelled it wrong though. Intersecting. Alright, there it is. Alright, let's go ahead and sketch it out real quick. Let's find that meeting place. So we're just going to eyeball it, you know what I'm saying? So let's see. We'll need midpoints. So that looks like about the midpoint. Now if you have a ruler or something, it'll work even better. But those 3 points seem to be about the midpoints to me. And now I'm going to draw a few perpendicular bisectors. Okay, so if I'm trying to draw this like perpendicular as best I can. Okay, that looks pretty good. Let's see, what color should I use? Purple? No, I think I'll do green. Okay. I'm going to do one from this other side. Alright, perpendicular. I might have to stretch it out a little bit more, won't I? Whoops, I wanted that to be green as well. Okay, so it looks like I might have to stretch it. Alright. So, it's looking like right about here is where the circumcenter is going to be. Alright, so this spot right here, that should be the meeting place. Okay, that last little perpendicular bisector, it only takes two, but that last little guy is too short to really see that well. But that's okay. Oh man, I messed it up. Alright, it's in there. The last little guy is in there. Okay, so there it is. Perpendicular bisectors meet. There's the circumcenter. So that should be the meeting place. Okay, so meeting place is circumcenter. Alright, and there it is. Maybe I should sort of show that these are perpendicular bisectors, yeah? Okay, but that's perpendicular, that makes it a bisector, right? Okay, if I mark these the same, alright, perpendicular you get it. I'm overthinking it, it's too much. Alright, longest homework assignment ever. I feel like we've done tests that were not this long. Alright, in fact, the last test you guys did, the video only took me 3 parts. And this is 4 parts. It's crazy. Crazy. I hope it was helpful, guys. I will see you on the next video.